Hi guys, in today's lesson, I'll be teaching us the nuclear symbol of an element alongside with isotopy. So if this is your first time coming across my video, I want you to subscribe to my YouTube channel and also follow my Facebook page at Brainwave Online Chemistry Tutorials. So let's commence with the class. Before I commence with the class, if you have not watched my previous video on atomic structure, I want you to watch that video so you get the full gist on atomic structure, so that when I start explaining some stuff about nuclear symbol of an element alongside the isotopy, it's not be a big deal to us. So let's get started with the class. Now please take note that the nuclear symbol of an element can be denoted with this. So please take note that this symbol refers to as what? The nuclear symbol. Please take note that this symbol refers to as what? The nuclear symbol of an element. So please take note that this symbol refers to as what? The nuclear symbol of an element. Also please take note that at the top left hand side we have A here, whereas the down left hand side we also have what? Z here. And please take note that A represents what? Mass number. Hereby Z here represents what? Atomic number. So A here represents what? Mass number, and Z here represents what? Atomic number. Watch my previous video on atomic structure so you get the full gist about what? Mass number and what? And atomic number. Please take note that because mass number is up, this refers to as what? Superscript. Superscript. And because what? Atomic number is down, it is referred to as what? Subscript. So please take note of this. And also please take note that this nuclear symbol of an element can actually be represented by what? By a symbol of an element. So please take note that you can also represent this symbol here by any symbol of an element. Hereby A here will be what? The mass number of the element, and Z here will be what? The atomic number of what? Of the element. Don't worry, when I'll be explaining isotopy, I'll talk more about what? About this. So just continue with the class, stay to the end of what? Of the class. Now, having explained all this, now let's now move straight away to what? To isotopy. Now, please take note that isotopy is the phenomenon where the atoms of an element that are what? Having what? The same atomic number but different mass number due to the difference in the number of neutrons. So that's what isotopy is talking about. Isotopy simply refers to what? To the phenomenon where the atoms of an element have what? Have the same what? Atomic number but different mass number due to what? To the difference in the number of neutrons. So that's what isotopy is talking about. Now, why is it that they are having what? Different mass number? Now, the reason why they are having different mass number is because of what? The number of what? Number of neutrons. Because of what? Number of neutrons. So because of the number of neutrons, that's the why they are having what? Different mass number, but what? The same atomic number. So please take note of this. And also please take note that there is a difference between what? Isotopy and what? And isotopes. So please take note that there is a difference between what? Isotopy and isotopes. Please take note that there is a difference between what? Isotopy and what? And isotopes. So you should please take note of this. Now, isotopy is a phenomenon whereby atoms of an element have the same atomic number but different mass number due to the difference in what? In the number of neutrons, like I've explained earlier on. Now, what about isotopes? Now, isotopes are the atoms of the element exhibiting the phenomenon which happens to be what? Which happens to be what? Isotopy. So isotopes, they are what? They are what? The atoms of the element exhibiting the phenomenon which is what? Isotopy. It's just like parents and what? And children. Now, parents come together to give birth to the children. Now, when they give birth to the children, they transfer their characteristics or their characters, some of their characters to what? To the children. But the children, they are not the owner of the character. That is, they exhibit the character from what? From their parents. So that's the connection and also the difference between what isotopy and what and isotopes. Now isotopy is the phenomenon whereby atoms of an element, they are having what? The same atomic number but different mass number due to what? The number of neutrons. Now isotopes are the atoms of the element exhibiting what? Exhibiting the isotopies. Exhibiting what? The isotopy, yeah. So please take note of this. So from here, we'll be moving straight to what? To some various elements and their various isotopes. So we'll be moving straight to it. Please take note that as isotopes, they are formed by representing what? By using what? The symbol of the element and alongside what? With the mass number of the element and the atomic number of what? Of the element. Don't worry, when we start using elements now, you will understand what I'm trying to say here. So let's talk about some elements and their various isotopes. Now, one of the elements that exhibit what isotopy is what? Is hydrogen. And let's talk about what? Hydrogen. So hydrogen, please take note that hydrogen exhibit what? Isotopes. And please also take note that hydrogen have what? 3 isotopes. Please you take note that hydrogen has what? 3 isotopes, and they include hydrogen 1. We have what? Hydrogen 1. We have hydrogen 2, and also have what? Hydrogen 3. So these are the 3 what? Isotopes of what? Of hydrogen. Now if you look at it very well, you see that their atomic number are the same, but their mass number are not the same due to the number of what? Of neutron. It is the number of neutron that makes the mass number not to be the same, but their atomic numbers are what? Are the same. So this is what isotopy is simply talking about. And these are the isotopes of what? Of hydrogen. So if you please take note that hydrogen has what? 3 isotopes. If you please take note of this. And now, please take note that this hydrogen here, which is hydrogen 1, this first isotope of hydrogen is known as what? Protium. It's known as what? Protium. It's known as protium. Why this second isotopes of hydrogen here is known as what? Deuterium. It's known as what? Deuterium. Why this third one here is known as what? Tritium. So this third one here is known as what? Tritium. So these are the various what? Isotopes of what? Of hydrogen. Now let's move to another element again that what? They also exhibit isotopy. Now another element again that exhibit isotopy is what? Is carbon. This thing that carbon also what? Exhibit what? Isotopy. And please take note that carbon has what? 3 isotopes, and they include, we have carbon 12, also have carbon 13, also have carbon 14. Carbon 14 is used for what? Carbon dating. Please take note of that carbon 14 is used for what? Carbon dating. So the 3 of them include what? The isotopes of what? Of carbon. So you please take note of this. Now let's talk about another element again. They also what? Exhibit isotopy. Now another element again that exhibit isotopy is oxygen. Take note that oxygen also exhibits what? Isotopy. Oxygen. And oxygen has what? 3 isotopes, just like what? Carbon and what? And hydrogen. And they include what? Oxygen 16. We have what? Oxygen 16. We also have what? Oxygen 17. And then we have what? Oxygen what? 18. So the 3 of them what? They include what? The isotopes of what? Of oxygen. Now let's talk about another element again. They also what? Exhibit isotopy. Now another element again what? That exhibit isotopy happens to what? Chlorine. In fact, chlorine is one of the major elements in the periodic table that what? Exhibits what? Isotopy. And please take note that chlorine exhibits what? 2 isotopy, and they include they include what? Chlorine 35, 17, chlorine 37, 17. So the two isotopes of chlorine include what? Chlorine 35 and what? And chlorine 37. So these are some of the elements that what? That exhibit what? Exhibit what? Isotopy. So you should please take note of this, and these are the various isotopes of this element. Hydrogen has what? 3 isotopes. Carbon has what? 3 isotopes, which include carbon 12, carbon 13, carbon 14, used for dating. We'll talk about what? Oxygen. Oxygen has what? 3 isotopes also. We have oxygen 16, oxygen 17, and what? Oxygen 18. Chlorine also have what? 2 isotopes, chlorine 35 and what? And chlorine 37. Please take note of this. Earlier on, I said that the isotopes of an element is simply be represented by what? By using the symbol of the element alongside with what? The mass number and what? And the atomic number. So these are the ways to represent what? Isotopes of what? Of a particular element. And these are some of the elements that exhibit what? Isotopy, and these are their what? Are their isotopes. So please, we should take note of all these that I've just brought out right now. So from here, under isotopy, I'll be giving us one formula for calculating what? The relative atomic mass. So I'll be giving us a particular formula for calculating what? Relative atomic mass under what? Under isotopy. Now the formula is, please take note of this formula. We have what? Rho AM equal to, now please take note that Rho AM means what? Relative atomic mass. Relative atomic mass. So please take note that ROAM means what? Relative atomic mass. So relative atomic mass equals to what? Equals to first mass take note of this, first mass times first abundance, times first abundance in nature. Then you will go to bracket it. Please take into this formula plus second mass plus what? Second mass. Okay, let me put it down. Second mass times second abundance in nature you also go to what? To bracket this also. So the addition sign is here. You also go to what? To bracket this also. Now also have dot here. Now what this represents is this, according to what? According to the what? To the, well, you know, earlier on when I was explaining the various isotopes of a particular element. Now there was an element that have 2 isotopes. There's an element that have what? More than 2 isotopes. Like what? Like oxygen, like carbon, like hydrogen. Now they have what? More than 2 isotopes. Now any element that have more than 2 isotopes, now you now include what? Third mass and third abundance in nature. Now please take note that over 100, please take note of this, over 100. Now this formula is used for what? This formula is under what? Under isotopy, and then this formula is used for calculating relative atomic mass under isotopy. Now in the situation when you are being asked to calculate what? Relative atomic mass, now, and they will actually give you some of the isotopes of what? Of a particular element. And you'll be asked what? To find what? Relative atomic mass. Now if you are asked to find relative atomic mass, now the isotope of the element, if it was 2, if it's any element that has 2 isotopes, actually like chlorine, now for example, that has 2 isotopes, which chlorine 35 and chlorine 37. Now you are only going to use what? First mass times first abundance in nature plus second mass times second abundance in nature. Now because the reason why you're only going to use these 2 is because what? That element which is happen to be chlorine has to what? 2 isotopes. That's the reason why you are going to use only these 2. Now assuming it was element that has 3 isotopes, like oxygen, which have what? Oxygen 16, oxygen 17, and oxygen 18. We will now include what? Third mass times third abundance in nature divided by what? By 100. That's the reason why I put this here. So you please take note of what? Of this. Now, please take note that this formula is for calculating what? Relative atomic mass under what? Under isotopy. Please, candidates and Javites, please take note of what? Of this formula. This formula is very what? Vital and what? And very helpful. Now, before I end the class, now please take note that the instrument for determining the number of isotopes under what isotopy is known as what? The mass spectrometer. Please take note of this instrument, mass spectrometer. Please take note of this instrument, mass spectrometer. So please take note that the mass spectrometer is used for what? It's used for determining the number of what? Isotopes of an element. So mass spectrometer, like I said earlier on, is used for what? For determining what? The number of isotopes of what? Of a particular element. So please take note of this. So with this, we have come what? To the end of this class. Like I said earlier on, if this is your first time coming across my video, don't forget to subscribe to my YouTube channel and also follow my Facebook page at the Brewwave Online Chemistry Tutorials. Don't forget to like my videos, to comment, and also to also share to your friends. Thank you guys for staying to the end of this class. See you in my next video. Bye.